Hello friends, I am Gauri Bhote, Assistant Professor in First Year Department Baramati. I welcome you all to my video lecture of subject Numerical Method, and topic of today's video lecture is Gauss Elimination Method and Gauss Elimination using partial pivoting. Okay, so here we see numerical methods. So we see numerical method for finding solution of system of linear equations. So there are two methods. One is direct method, another is indirect method. So in direct method, we see Gauss elimination, then Gauss elimination by partial pivoting, LU decomposition and Cholesky method. And indirect methods are Jacobi's iterative method and Gauss-Seidel method. So direct method means from given data and indirect means iterative methods. So numerical solution for system of equation. So we are familiar the system of linear equation. M equation in n unknowns are given as a11x1 plus a12x2 plus a13x3 plus dash dash a1nxn is equal to b1. a21x1 plus a22x2 plus a23x3 plus a2nxn is equal to b2. And am1x1 plus am2x2 plus am3x3 and so on, amnxn is equal to bm. This is system of m equations in n unknowns. And to solve such equations, we have some methods, but if sometimes coefficients are like fractions or complicated coefficients, at that time we cannot use matrix method or our previous method, and in that case we are using numerical method. So first we see direct first method, Gauss elimination. So here in Gauss elimination method, what we do from given equation, suppose we having m equations, first, second and so on. Suppose we have m equations. So I substitute the value of x1 from equation 1 in terms of remaining variables actually, and we substitute that value here in terms of x1 in remaining equations, and we eliminate x1 from remaining equations, and we get new system of m minus 1 equations which are in terms of x2, x3 and xm minus 1. Similarly, I eliminate x2 variable from next system and I am finding system of remaining equation. So in this way, at the last you get last value of xn. Some xn is equal to k, and again by using back substitution we are finding the value of remaining solutions. Okay. So let us see one example. What is Gauss elimination? So if I have system of two equations in two unknowns, 2x plus y is equal to 5, and second equation x minus y is equal to 1. So I have two equations in two unknowns. So first Gauss elimination method, from equation 1 I reduce or I write x in terms of remaining variables. So I write x is equal to 1 by 2 times 5 minus y. Here I shift this y to RHS, so it becomes 5 minus 1. And when I shift this 2, so it becomes 1 by 2. So 1 by 2 times 5 minus 1. And I put this value of x in this equation 2. So put this value of x in equation 2. What I am getting? Equation 2 becomes, here x is 1 by 2 times 5 minus y, and here this is the value of x, I substitute, minus y is equal to 1. So I simplify this, what I am getting? 5 by 2 minus y by 2 minus y is equal to 1. So after writing, take this 5 by 2 RHS, minus y by 2 minus 5 becomes minus 3 by 2y is equal to 1 minus 5 by 2, and simplify this, 2 minus 5, that is minus 3 upon 2. So 3 by 2y is minus 3 by 2. What it gives? Y become 1. This minus 3 by 2 get cancelled. Y is equal to 1. Now we get value of y. We substitute in this equation. Suppose I say star. So sorry, here in this equation I say star. So what is my x become? X is equal to 1 by 2 times 5 minus 1. So it becomes 4 by 2, that is 2. So we get solution x is equal to 2 and y is equal to 5. Sorry, y is equal to 1. And if you cross check, 2 into 1, 2. 2 into 2 plus 1, 5. 2 minus 1, it is 1. So this satisfies the given. So this is the Gauss elimination method. What I do, I from first equation eliminate first variable. I substitute that value in next equation and I will eliminate x1. So I get value of second variable y. And if we get value of second variable, we back substitute this value here and we get value of x. Now we see example. So solve system of equations using Gauss elimination method. So system is given 2x plus 4y plus z is equal to 3. 3x plus 2y minus 2z is minus 2. X minus y plus z is equal to 6. So what is step 1? From equation 1, write down x in terms of remaining variable. So I write x is equal to 3 minus 4y minus z into 1 by. So x becomes our, I write equation star, this is x is 1 by 2 into 3 minus 4y minus z. Now I substitute this value of x in remaining two equations. So equation 2 becomes 3 times x. So 3 into 1 by 2 times 3 minus 4y minus z plus 2y minus 2z is minus 2. So I simplify this, 3 by 2 into 3, that is 9 by 2. 3 by 2 into 4, so it becomes 6 minus 6. Then minus 3 by 2 plus 2y minus 2z is minus 2. So this plus 4 minus 6y plus 2y, it becomes minus 4y. Minus 3 by 2 minus 2z. So it becomes minus 7 by 2z. And I shift this 9 by 2 to RHS. So 2 minus 2 minus 9 by 2. So 2 into 2 minus 4 minus 9 minus 35. So I get new equation in terms of y and z. So which is I give equation 4. Similarly, from equation 3, I substitute value of x is 1 by 2 into 3 minus 4y minus z, and remaining term minus 5 plus z is equal to 3. So collect the terms of y together. So minus 4y into 1 by 2 minus 2y minus y, that is minus y, minus 1 by 2z plus z, that is plus 1 by 2z is equal to 6, and minus this 3 by 2, so minus 3 by 2. So 12 minus 3, that is 9 by 2. So in this way we get equation 5. Now equation 4 and 5 are my new system of equations in variable y and z. So again this is my first equation in y and this is my y and z. This is my second equation and I eliminate first variable y. So what is it? Y is equal to minus 13 by 2 minus minus plus 7 by z into minus 1 by 2. If I multiply minus 2 by 2, it becomes y is equal to 1 by 4 times 13 by 2 minus 7 by 2. So I get Now we put this value in equation 5. What is equation 5? 3 times y. So 3 times 1 by 4 into plus 13 by 2 minus 7 by 2z plus this 1 by 2z is equal to 9 by 2. So simplify this. 3 by 4 minus into 7 by 2. So it becomes 3 into 7, this is 21 by 8 divided into z. Then here plus 1 by 2z and this 13 into 3 minus 39 upon 4 into 2, 8. Now 21 by 8 plus 1 by 2z, it means multiply 4, so it becomes 4 by 8, so 21 plus 4, 25 by 8z is equal to 9 by 2 plus 39 by 8. Again multiply, divide by 4, so here you get 36 plus 39, that is 74 by 8. And this 8 get cancelled, 24 into 1 and 3. So we get z is equal to 3. Now we get value of z is equal to 3. We substitute this value in equation 2 star here. Substitute the value of z. So what we are getting? Z is equal to 3. That is y become 1 by 4 into 13 by 2 minus 7 by 2 into 3. So if we simplify this, 13 minus 21, that is minus 8, and this minus 8 by plus 8, that is y become minus. Again substitute this value of y and z in equation start. So x is equal to 1 by 2 times 3 minus 4y minus z. So substitute this value of y and z. So y become minus 1, z become 3. And simplify this, we get x is equal to 2. So in this way we get solution x is equal to 2, y become minus 1, z is equal to 2. So this is the Gauss elimination method. Now similarly you can solve Gauss elimination method for second system. 3 equations in 3 unknowns are given. Eliminate x1 from first equation and substitute here in the next 2 equations. Again you get new 2 equations which are, suppose this is my x2 and x3 equation. Okay, and you will get answer. Okay. Now we see next Gauss elimination using partial pivoting. So what is Gauss elimination using partial pivoting? So first we see what means pivot element for xi. So if given system of equation, then pivot element for xi is numerically largest coefficient. So pivot element for xi is numerically largest coefficient of xi. So numerically means we consider with plus or minus n, magnitude sign. So pivot element for x1 is maximum of this mod of a11, mod of a12, mod of a13 and a1. So numerically largest coefficient. So if we see equation 1, so coefficient of first equation of x1 in first equation is 1. In second equation it is 4 and in third equation it is 3. So maximum number out of this 1, 4 and 3, 1, 4 and 3. So maximum number is 4. So it is 4 is the pivot element. Now second equation, it is 2x1 plus x2 minus 2x3 is 3, whatever. So coefficient of x1 is 2. In second equation, coefficient is 1. In third equation, coefficient is minus 3. So if we consider magnitude, so here it is 2, mod of a21 is 1 and mod of minus 3 is 3. So largest coefficient numerically is 3. So pivot element for x1 is okay. So this equation we consider for calculation. Now what is partial pivoting method? So this is the method, slightly similar changes in Gauss elimination. and very similar to Gauss elimination. So in partial pivoting, so we select equation 1 is the equation which contains pivot element of x1, and we rearrange it and we take this equation 1. And now we eliminate x1 from that equation. Here normally what we do, I select this is my 1, this is my second equation, and this is my third. But in partial pivoting, we select this is my equation 1, and I select this is to eliminate x1. This is my remaining equation is 2, and this is my third equation. Okay. And now again we reduce as the previous one, new system of equation, and to find out x2 again we are using new system of equation. Like as here I having equation 4 and 5. So what is equation 4 and equation 5? Minus 4y minus 7 by 2z and minus 3y plus 1 by 2z is equal to 9. So again here numerically largest coefficient of y is this. So this is my pivot element, and I select this equation to eliminate y. So this is the partial pivoting method. Okay. So we get new system of equation, that means equation 4 and 5, and we find out pivot element for x2 and give that equation is next number 4 or whatever, and we eliminate that x2 from that equation and again obtain new system, and we continue or repeat the procedure for remaining. Okay. So it is similar to Gauss elimination, only by selecting the equation for which we eliminate, we select the equation which having largest coefficient, numerically largest coefficient. Okay. So see the example. So solve the given system of equation using Gauss elimination partial pivoting. Okay. So here given system of equation is x1 plus x2 minus 2x3 is equal to 3. 4x1 plus 2x2 plus x3 is equal to 5. 3x1 minus x2 plus 3x3 is equal to 8. So here normally we eliminate x1 from this equation. But for partial pivoting, we find out the equation which having largest coefficient. So here it is 1, 4 and 3. So largest coefficient is 4. So this I select as my equation 1 to eliminate x1. So I rearrange my system. I take my equation 1 is 4x1 plus 2x2 plus x3 is equal to 5. Which equation? Which I take first equation in which having numerically largest coefficient for x1. Okay. Then remaining equation x1 plus x2 minus 2x3 is 3. 3x1 minus x2 plus 3x3 is equal to 8. This is my equation 3. Now by previous method, I write x1 in terms of remaining variables. So x1 is equal to 1 by 4 times 5 minus 2x2 minus x3. Here I take this minus 2x2 minus x3 and into 4 it becomes 1 by 4. So it is 1 by 4 times 5 minus 2x2 minus x3, and I substitute this value in equation 2 and 3. Okay. So after substituting this value, what I am getting? New equations. 1 by 2x2 minus 9 by 4x3 is 7 by 4, and minus 5 by 2x2 plus 9 by 4x3 is equal to minus 11 by 7. So which equation we select to eliminate x2? Which having largest coefficient, numerically largest. So here coefficient of x2 are 1 by 2 and minus 5 by 2. So if we consider mod, it becomes plus 5 by 2 and 1 by 2. So this is numerically largest. So therefore pivot element for x2 is minus 5 by 2, and we eliminate x2 from this equation. So how we write x2? It becomes I shift this term actually to RHS. So here 9 by 4 x3 plus 17 by 4 into this 5 by 2. If I shift another side, it becomes 2 by 5. And now I substitute this value of x2 in other equation. So I substitute in equation 4. So I get equation 4 is 1 by 2, I keep as it is. Then I substitute value of x2 which I obtained here. So this is 2 by 5 into 9 by 4 x3 plus 17 by 4 minus 9 by 4 x3 is equal to 7 by. So simplify this 2 into this 2, it gets cancelled. So here 9 by 4, 9 by 10 x3 minus 9 by 4. Then we are getting plus 17 by this 2 will get again cancelled. And after simplification, we are getting value of x3 here is equal to minus 1 by 2. So if you want, you simplify this. What we are getting is 2 get cancelled. So it becomes 9 by 10 x3, 9 by 10 x3 minus 9 by 4 x3, and this is equal to 7 by 4 minus this 2 get cancelled, 17 by 20. So simplify this. So by 4 is there. So I multiply this by 2 and here by 5. So what I am getting? Denominator is 20. So 18 minus 9 into 5, 45. So simplify this. 18 minus 45. So it is minus 27. And here is also do the calculations. 17 by 20. So we have to multiply it by 5. So 35 divided by 20 minus 17 by 20. So if you subtract this, so we are getting 18 by 20, and if you simplify, you get x3 is equal to half. And again, if we back substitute this value of x3 here, we will get x2 is 5 by 4, and then back substitute the value of x1 and x3 in this equation 1 where we eliminate. Here in this equation we substitute x2 and x3, we are getting value of x1. So in this way we get the solution for x1, x2, x3, 3 by 4, 5 by 4 and minus 1 by 2. Okay. So here I think we stop. So thank you so much, and to watch more videos you subscribe my channel. So thank you. Happy learning.